Hello friends, welcome to Data Science with Molloy. 5 minutes of vlog with Molloy on data science. Today we will talk about time series analysis. This is the part of lecture I gave to my JI, SI, ASR students. So time series in mathematics is a series of data points indexed or listed or graphed against time in x-axis. So there should be time in x-axis, that is the time series. Time series analysis. Time series analysis comprises methods for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. Time series forecasting is the use of a model to predict future values based on the previously observed values. So let's see if we can fit some model using time series in the data. So I took the US election result counting in 2024. So these are the status for different time at different time points. Finally, Trump won. So this is a time series data. I looked at it as a time series data, and one can tabulate the times at which the data is observed, and these are the votes between Trump and Kamala, and this is the difference. Finally, with 277 seats, Trump won against 224 by Kamala Harris. Difference was 53. So this is time series data. We have time at the x-axis. These are some analysis. This is the curve for Trump. This is the curve for Kamala Harris. And this is the differences with I tried to fit a linear curve which is slightly increasing, showing the probable win by Trump against Kamala. And this is the cubic fit curve, etc. And time series modeling. When modeling variations in the level of a process, three broad classes of practical importance are autoregressive models, integrated models, and moving average models. These three classes depend linearly on the previous data points. Combinations of these ideas produce autoregressive moving average ARMA and autoregressive integrated moving average ARIMA models. The autoregressive functionality integrated moving average generalizes the format 3. Among other types of nonlinear time series models, these are models to represent the change of variance over time heteroscedasticity. These models represent autoregressive conditional heteroscedasticity arch, and collection comprises of a wide variety of representation: GARCH, TARCH, E-GARCH, F-GARCH, G-GARCH, etc. These are called GARCH models, which are nonlinear in nature. ARIMA PDQ models, autoregressive integrated moving average models. ARIMA models are used to denote ARIMA, usually denoted ARIMA PDQ, where parameters PDQ are non-negative integers. P is the order of autoregressive model, D is the degree of differentiating the number of times the data have had past values subtracted. Q is the order of moving average model. Mathematical modeling: xt t greater than 0 be the time series, and we model xt as mu t plus epsilon t, where mu t is the long-term trend and et is the noise. And more explicitly, we write xt equal to mu t plus st plus ct plus epsilon t, where the long-term trend mu t, st is the seasonal trend with regular seasonal fluctuation, ct is the cyclical trend, and et is the noise in the error term. Autoregressive model, summation phi I xti, moving average of order q, mu plus summation theta I epsilon t minus I plus epsilon t. So this is the two parts of autoregressive model and moving average model. And for integrated, the parameter d for integrated model, xt is called stationary if the time series, if for tau xt t1 t2 tn is distributed as xt1 plus tau t2 plus tau tn plus tau. So if if this pattern matches the pattern of xt1, xt2, xtn, and xt1 plus tau, xt1 plus t2 plus tau, xtn plus tau, if the distribution matches for any term, we call it a stationary series. And we take differences. Xt minus 1 is the first difference. This is called 1 minus L xt, where L is the lag operator. So if we need to take difference d times to make the series stationary, the integrated parameter d is this value. How many differences we need to take to make the series stationary. And this is the mathematical formulation of Arimo-PDQ process. This is the autoregressive part. This is the moving average part. No, this is the moving average part. This is the autoregressive part, and this D is the integrated part. So using these three concepts, we get the Arimo model. And there is one more concept. We can introduce covariates in the model, which is quite useful while do some predictions or forecasting. So we call it Arimo with covariates when we use covariates in the model. Thank you. It's a brief discussion of time series model, time series analysis. Like, comment, share, subscribe my video. Available for one-to-one discussion too. Thank you.